Oh, good. Hey everyone, thank you so much for joining us here at KHOU for our weather classroom. This is our journey into the weather world and bringing it into the classroom, getting the chance to show you, everyone sitting at home, getting the chance for learning a little bit more about the weather world that surrounds us. And I'm meteorologist Addison Green. Thank you so much for joining us, and apologize for the delay. We had a little technical issue here on our end, but things are starting to get cleaned up. So hopefully everyone can see me at home. So looking right here at the weather classroom week 1. Yesterday we covered all things weather. What is it and why do we have it? Chief Meteorologist David Paul was covering that lesson for you. Today I'm talking about the atmosphere, the water cycle, clouds, and rainbows. And then tomorrow we have a little bit switch in the syllabus. We're going to be covering Houston disasters and our vulnerabilities on Monday's time frame. Instead, for tomorrow, we're going to be talking about how we do have the chance for talking about severe weather across our area in the form of tornadoes. We'll even cover some microbursts and hail activity as well. Then as you go through next week, Tuesday, Wednesday, all the way through Friday, here are our topics of discussion: hurricanes, tropical storms, ENSO, as well as on the 25th, on Wednesday, the final frontier: space, planets, stars, Earth's final demise. Hopefully not for a long time. Thursday, March 26th, weather safety, safe places you need to take into consideration whenever inclement weather is coming your way, whether it's severe weather, tropical weather, hurricane preps, flood safety as well. And then on Friday, March 27th, we are talking about forecasting and how we are going to help you make the forecast together with us. So just a little bit of some Weather 101 we're trying to bring into the homes while everyone is home during these turbulent times. So here we go, the water cycle, I should say. So we all know about the skies up around us and the land that we are standing and walking around on, as well as the bodies of water like the Gulf of Mexico that help to give us nice, beautiful, scenic shots from time to time. Well, eventually, as the sun shines on down, we get the chance for the sun to heat up the bodies of water. Talking about the Gulf, local rivers, streams, creeks, any body of water, heats it up, and we have those little water vapor particles going up into the atmosphere via evaporation. Eventually, those water particles condense and coalesce around specks of dust and little floating particles in the atmosphere, and slowly but surely over time, we get the chance for clouds to build on up. Eventually, those clouds continue to get more and more moisture coming into the picture, and they continue to condense that moisture in those clouds. And eventually, when those clouds can no longer sustain all that moisture in the atmosphere, they start to precipitate it down towards the surface in the form of rain, and in some portions of the country and the world as well, in the form of snow or even a little wintry mix. Thankfully, here in the Houston metro area, we mainly see precipitation in the form of light to moderate, even sometimes heavy rain. Very seldomly do we get wintry mix to even snow, but that does happen from time to time. Well, eventually, all that precipitation falls to the ground. The ground can only absorb so much, kind of like your sink's sponge. There we go. I'm trying to think of the word. It can only hold so much before it starts to run off that sponge and drip down your hand. Well, the ground can only absorb so much before it starts to run off, and eventually starts to run downhill due to gravity down towards local creeks, streams, bayous, which eventually empty out into, say, the Gulf of Mexico, for instance. And it's going to be the end of the water cycle, but as the wheel goes round and round, we repeat the cycle, starting to go through evaporation, condensation, precipitation, and as well as runoff. So yeah, there you go. There's a cycle in its entirety right there, and we need this cycle in order to maintain the life that we know around the Earth to be mainly on the nice and even and smooth side of things. Now, when we talk about a rainbow, it does look very beautiful, but how does it form? Well, it's in contribution to the water around us, as we do see the sun emitting white light, which is composed of every color of visible light. It's what you look outside and you can see clearly that white light shining on down. But as raindrops fall down, we have the spectrums of light being separated, and we can see via refraction those different colors going on in the atmosphere. And you can see all the colors right here for us. We have red, orange, yellow, green, blue, indigo, and violet. An easy way to remember that is Roy G. Biv. That's all the colors of the rainbow right there and their abbreviation forms. And that's why I learned in science class a good way to remember the colors of the rainbow right there. And as you can see, we have the raindrops then reflect that light into what we see as a rainbow. Sometimes you may see a portion of a rainbow. Sometimes you can see the full arc. And even up aloft, I've seen photos and videos of people showing the entire circle of a rainbow if, say, they're flying in an airplane, and just happen to be at the right angle. Also, the sun, when you're talking about a rainbow, has to be setting towards the horizon when you're getting the chance to see a rainbow in its entirety. So usually the best chance to see a rainbow is going to be in the late afternoon hours. Usually after a typical, say, summer thunderstorm develops, pushes across our region, the rain comes down, and then as it pulls away from us, with that sunlight shining on the back end of it, you get the chance for seeing that rainbow to shine on down. So yeah, pretty cool notion right there. And whenever we get the chance to see one, it's usually a nice way to end the day, considering what you just had to go through in the form of those possible strong to even severe thunderstorms, even just light to moderate rain. So we'll take any questions you may have, and if you have any thoughts and concerns with the weather around us, feel free to put them on our Facebook page. We'll be glad to try and answer as many as possible. So I'm gonna go ahead and check in with Randy to see if we do have any questions. Randy? Mm-hmm. Sure. Hey, Emily. That is typically found to be the case whenever you have possibly some fog concerns, and we call those fog bows. So you do have moisture droplets in the atmosphere just kind of hanging around, almost like suspended in the atmosphere, like they're just floating around. And as you get the light to shine on down at a certain angle, you get the chance for seeing those little rain droplets refract the light and giving us a partial rainbow. You won't see the full rainbow like you typically do see in the afternoon hours, but you'll see some. And that's what we typically call a fog bow. There's even a moon bow, which happens during the nighttime hours with the light being reflected off the moon, I should say, and getting the chance to shine down towards us. If there's enough moisture in the atmosphere and you're at the right angle, you can possibly see like a little bow of sunlight being visible in the atmosphere. Sure. Hi, Lisa. Hi, Lisa Emberson. Mm-hmm. Who's in danger for tornadoes, you say? Okay. Well, typically this time of the year, we're going in towards the spring season. In fact, spring arrives later tonight at 10:50 tonight. That's when we welcome in the vernal equinox, and that's when spring arrives. So as we go through the spring season, we are now starting to see the jet stream starting to drift further northward. And as it does so, we're switching out the colder, drier air masses that have dominated much of the winter months across much of the country and replacing it with the warm, muggy air mass from the south. Well, as you're replacing those air masses, they tend to clash, and that's when you get severe weather and then potentially the possibility of tornadic weather. Us here in southeastern Texas, we do get the chance for seeing a few tornadoes. They're usually EF0s or EF1s, sometimes even EF2s. But those big, violent tornadoes that you typically find across the plains, those massive tornadoes you typically see in movies, those are usually residing in places like Oklahoma, Kansas, Missouri, over across that way. That's what we call Tornado Alley, pretty much from northern Texas all the way up towards the Dakota, South Dakota to be more precise. And there are other tornado alleys across the country. You have Dixie Alley, Hoosier Alley, and I believe one other alley across the southeast. I'm kind of forgetting the name right now. Sure. Well, let's go ahead and look back at the graphic right here for you. Why the rainbows are different colors? Well, we have that sunlight coming off from the sun, of course, and it's traveling millions of miles. It gets to us roughly in about 8 seconds or so, 8 minutes or so, I should say. And then as we see that light come down and we have rain droplets in the atmosphere, we get that light to be refracted by those raindrops. And since light travels at different wavelengths, each one of those colors travels at different wavelengths. So if we have more of a chance for seeing possibly the darker side, the left side, I should say, of the spectrum right there, we'll see more red and more orange. But sometimes we can maybe see just maybe the right side of the rainbow right there. A little blue, a little indigo, a little violet. But typically you will see all the colors of the rainbow because that white light is hitting those rain droplets and being refracted in all directions. And we're getting the light to be broken out into red, orange, yellow, green, blue, indigo, and violet. And indigo is kind of like that bluish, purplish color. Hi, Becky. Michelle? Well, typically, when we are talking about a rainbow, we're getting the chance for maybe seeing a portion of it, but every now and then we can see the full arc. And the only way you really don't get a chance to see the full arc is usually because there's something obstructing your view, or we have the atmosphere becoming a little bit too saturated. So we're not seeing that full chance of getting the full rainbow, I should say, to be visible, but only a portion of it, because maybe there's a little bit of some haze right here going on in this portion of the sky. So it kind of refracts the light a little bit more so than what you would ideally want to get those colors to be clearly visible. So sometimes you just see a portion of the rainbow and then it just kind of fades away. So sometimes we don't have the most ideal conditions to get the rainbow, but every now and then we can see the full rainbow. And if we have nothing obstructing our views, say like a nice open field, you can see from end to end the rainbow. And maybe you can go ahead and find that pot of gold at the end of the rainbow people are always looking for. Sure. Hi, Shannon. Yes, rainbows do get the chance for touching the ground, but more times than not, they are usually just out of reach. And that just depends upon where the clouds are that are producing the rain as compared to where the sun is in that distance right there. Sometimes you get the chance for being real up close to a rainbow, but you just can't quite get to that location where that rainbow's coming on down. It's just a matter of spatial difference right there. But sometimes we can get the rainbows to go all the way down to the ground, but sometimes they kind of just get cut off a little bit above us. So it just depends on where you are. Every rainbow is different, kind of like a snowflake, and a raindrop, I should say, as well. Hi, Juliet. Clouds? Oh, clouds are made of water droplets and little water particles right there. Water vapor is what we typically get. I'll go ahead and go back to water cycle right there for you. And we go ahead and look at the eventual evaporation of the moisture from any body of water, or even the ground that has a little bit of some moisture in it. It can eventually get the chance for being heated up, and kind of like a pot of boiling water, you're eventually going to see a little steam rising from that pot. Well, that's evaporation right there. All that moisture is evaporating to the atmosphere aloft. And then as it goes up in the atmosphere, the temperatures are cooler aloft, so it slowly cools and condenses from being a gas to being a little water droplet. And sometimes it will get the chance for doing so relatively quickly. Sometimes it'll take a while to do so. Depends on how much moisture is in the atmosphere. But the water droplets need something to cling onto, kind of like latch onto it. And that's going to be a little particle of dust, a little vapor particle in the atmosphere. You get enough of those to condense around, and you'll see little puffy cumulus clouds, and those will gradually build on up during the summertime days, even the late spring days, and they'll continue to build on up towards those big, impressive, towering cumulonimbus clouds, and eventually they'll start to look a little threatening, I should say, due to condensation, and we continue to put more and more moisture in those clouds, and then eventually those clouds will precipitate out, and we'll get the chance for seeing those raindrops falling all the way down towards the surface, and then in which case they eventually will run off via several processes back down towards those bodies of water. But yeah, clouds made out of water droplets, and they weigh a ton. Picture like an elephant floating up aloft. That's how much a cloud weighs. But because it's made up of tiny little water vapor particles that weigh a fraction of what the weight is around them, but down here on the surface, you put so much of them together, they eventually will become no longer able to be supported by those updrafts of air rising up, and the clouds can no longer support them as well. To eventually, they rain on down. Hi, Becky. Tornadoes, they can get anywhere between the small, tiny little ropes, kind of like picture like your finger, to being maybe a mile, 2 miles. There's even been reports of possibly slightly wider tornadoes. So picture like a city block, for instance. That's how wide possibly some tornadoes can get. And it's all based on the parent storm system they are attached to. If they're really violent, really strong, they are really what we call breathing. They are sucking in so much air, and they are towering well up into the atmosphere. Picture like where a commercial jetliner flies. They're hitting that layer and maybe even going past that. Those big, powerful thunderstorms, those are the ones that have the chance for creating those very large tornadoes. But even smaller thunderstorms can create some small tornadoes, and we usually find them to be maybe about the size of, say, a car or a school bus in width. But we'll talk about more about tornadoes tomorrow. Hi, Laura. Hmm. The sun is really hot and heats the water up a lot. Well, the sun usually stays at a consistent temperature. It's just a question of how much do we get the chance for seeing that water being impacted by the incoming sunlight. There's only so many hours during the day that you have the chance for heating up that water. And water, unlike land, takes longer to heat up. So as we look at the equator right in the middle of the planet, hence the name, typically gets the chance for seeing all the sunshine coming on down more than anywhere else across the planet. So those temperatures usually stay uniform. But across the northern hemisphere or the southern hemisphere, that's when, because of the tilt of the earth, and that's why we have seasons, we see less sunlight coming on down across, say, the northern hemisphere where we're living in. And so we have less of a chance of the water heating up for long periods of a time, and we don't get the chance for seeing those temperatures rise. So it's all based on how many hours of the day we get the chance for heating up the water, and also based on the angle that the earth is tilted towards the sun. Mm-hmm. Hi, Teresa. Sure. Well, we're definitely going to try and talk more about that for tomorrow's lesson, but a little sneak preview is that hail and sleet, those are made by the same processes that are made roughly when you're making rain droplets form down, but also you're getting violent updrafts sucking in all that air. Well, eventually that air continues to rise, and then you have eventual downdrafts coming on the back end of it. But we're trying to get little particles going up aloft, and as they go higher up in the cloud, they will get colder and colder and will get harder and harder, and then they'll start to fall down because the cloud can only support it for so long. But then, as we have another violent updraft come on in, it knocks that little particle back up, and it continues to repeat that cycle over and over again, making that hail have more and more layers on it, almost like an onion, so to speak. Well, eventually, the thunderstorm, like raindrops, can no longer support that hailstone, and it'll come crashing down. The more violent the updrafts are and downdrafts, the longer we can sustain that hail particle in the cloud, and the bigger and bigger it can get. I've seen hailstones, I've seen pictures of hailstones, I should say, 8 inches long, so roughly about maybe that big or so. That's a very large hailstone. You do not want to get hit like that. That's like getting hit by a baseball bat, so to speak. But I've seen hailstones maybe like the size of a pea. So it just maybe like kind of like knocks you in the head a little bit. You feel like, what was that? So they can vary in size, but it's all based on the type of thunderstorm that is producing that hailstone and also the environment. If we have much more colder air aloft and much more warmer air down towards the surface, you'll get more of that violent clashing of the air masses, allowing that thunderstorm the chance to really strive and breathe and live longer and longer. Sure. What time is it? We got 2:45. Yeah, I got time for one more. Mm-hmm. All right, Tommy. Hi, Emmett. Mm-hmm. Is fog low because the clouds are heavy? Okay, so picture like a pot of boiling water. When you turn that pot on, at first you don't see much, right? And then eventually you start to see bubbles bubbling up from the top, right? But picture like the sun shining on down across the atmosphere, and it's slowly getting the atmosphere to heat up and rise up aloft. Well, eventually you turn that burn down to off on that pot, and eventually you'll see that water slowly start to settle. Well, as the sun sets, we're slowly losing that daytime heating. So all of that moisture in the atmosphere that's being suspended aloft will slowly sink down to the ground. The more moisture you have in the ground, the more moisture I should say you have up aloft, and the less wind you have to move it around, the more and more it's going to condense down towards the surface, and the more likelihood you're going to have patchy fog, maybe dense fog. And the thicker the fog, the less and less you'll be likely to see in front of you. I've seen fog where you can't see in front of your face like this far away, and there's some fog where you can see maybe a mile or so, and that's it, almost like a picture of like a creepy movie. So the fog depends upon how much moisture is in the atmosphere, and that usually depends upon the time of the year. Sometimes we can get more fog chances as we go towards the late winter months into spring in this portion of the country. And then in the summertime, you know, Houston, we don't have lack of moisture in the atmosphere. We always have a ton. So there's usually chances when there's not a lot of wind around to get that moisture to settle down towards the surface and possibly get us some foggy chances overnight. Mm-hmm. Hi, guys. I think we're getting a chance to start to break away shortly. starting to see some activity in the newsroom. Everyone, thank you so much for joining us here for day 2 of our weather classroom. Again, my apologies for it starting a little late. We have a little technology concern on this side of things, but we're glad the stream was up and running eventually and everyone could chime on in and join us. We'll be back tomorrow, hopefully at 2 o'clock. And we look forward to talking about, let's go ahead and back up the syllabus. We're going to talk about severe weather, tornadoes, microbursts, and hail. So a little bit of switch in the syllabus. Monday's lesson will come tomorrow. Friday's lesson, that's going to come on Monday. Meteorologist Blake Matthews will be talking about the Houston disasters and our vulnerabilities, especially when we talk about disasters like Harvey, as well as severe weather. You got to know what to deal with, and we're going to talk about all those disasters that have impacted Houston over the past several years. So thank you so much, guys, for joining us. I'm Meteorologist Addison Green, and definitely check us out at 4 o'clock for the 411. We'll have more news and weather information.